Hello everyone, welcome back to Matematika class. Today, we will discuss the example of Vieta's law, and I'm taking it from your book from exercise 4, page 283. So this is the example that relates every coefficient of the equation. In here, the cubic equation with the roots. In here, we have the equation with the roots, which is forming arithmetic series with different tree. And we need to find out the value of p and the roots of the equation. We suppose that the roots are x1, x2, and x3. So, we are starting from the list of the rules with the sum of the roots first. x1 plus x2 plus x3 is minus b over a. Since we can see that b is minus 6, so minus b over a is 6. This is x1 plus x2 plus x3. Next, we will relate the roots using the second formula, the sum of the product of the two roots. x1 x2 plus x1 x3 plus x2 x3 equals c over a. So we have the sum of the product of the two roots become, in here, the value of c is, let's make the list first. A is 1, B is minus 6, C is 3, and D is P. So C over A is 3 over 1, or it's 3. Next, since we have the relation between the roots forming arithmetic series, then in here, from x1 to x2, the difference is 3. From x2 to x3, the difference also 3. So that we can have the relation between x1 plus 3, it's x2, and x2 plus 3, it's x3. What next? We can substitute it to the first formula, to obtain the relation or one of the roots. Let's see in here, x1 plus x2 plus x3, we take it for the first equation. We will substitute x1 in terms of x2. We will let all of the equation in here in terms of x2. So we substitute x1, x2 minus 3, and then we have x2, and x3 is x2 plus 3. So that in here we have the sum 3x2 equals 6, x2 is 2. So in here we can find out x1 is minus 1, and x3 is x2 plus 3, so it is 2 plus 3 is 5. Find all of the roots, x1, x2, and x3. So we need the value of p. That's next, The value of p at the cubic equation is at the coefficient of d. So using the third formula, the product of the roots x1 times x2 times x3 is minus d per a, because d is in the position of d earlier. Minus d per a, it's minus p. So x1 is minus 1, x2 is 2, and x3 is 5. Then this is minus d per a or minus p. So we find that p is 10. Okay, so all of the questions are obtained. Next, we will try to solve number 8. We have the cubic equation x cubed minus 6x squared plus px minus 6. And then it is also has an arithmetic series of roots. And we need to find out x1 plus x2 plus x3 plus p squared. So, the first formula, the sum of the roots is minus b per a, or in here we also obtain the sum of the roots is 6. Next, using the arithmetic series relation, we will relate the x1, x2, and x3. Arithmetic series has common difference. It is added by a value. Suppose it is a b. Then, if you subtract x2 with x1 and x3 with x2, then we find out an equation 2x2 is x1 plus x3. Then, this is the second equation. We will substitute it to the first equation. X1 plus X3 is added with X2 and it's equal 6. We substitute X1 plus X3, which is 2X2. So it will be added with X2 becomes 6. 3X2 becomes 6. X2 is 2. Okay, so we find out the first root. What next? With the relation of 2x2 from the second equation, we know that x1 plus x3 is 2 times 2, it's 4. Next, we will try to use other formulas. I need one more relation to relate x1 and x3. So I can find the root. I will use the product of the roots x1 times x2 times x3, which is minus d per a. The product of the three roots will be, it's 6. And then I can substitute here. Yeah, in here I substitute x3 with 4 minus x1, so that at the third equation here, all in terms of x1. I have x1 times 2 times 4 minus x1 is 6, so that I have 8x1 minus 2x1 square minus 6 equal 0. We will solve this quadratic equation in terms of x1. Let's divide all by 2 and move it to the right. So we have x1 square minus 4x1 plus 3 equal 0. So that I can factorize and have the x1 minus 3, x1 minus 1 equals 0. x1 is 3, or x3 is 4 minus x1. So in here, x3 is 1. Yeah, so actually using the other roots, it is only the swap, yeah, of x1 and x3. It will be the same. The other two roots are 3 and 1. Last one, to answer the question x1 plus x2 plus x3 plus p square. Yeah, we need the value of p. P is at the c part, so I need to relate all of the roots using the last formula. x1 x2 plus x1 x3 plus x2 x3 is c over a. We substitute. x1 times x2 is 6, x1 and x3 is 3 times 1, and then x2 and x3 is 2 times 1. So that in here, we can calculate that the value of c over a, or the value of p, is 6 plus 3 plus 2, 11. Then we substitute here, x1 is 3, x2 is 2, x3 is 1, added with p square. So the value is 6 plus 121, or 127. Okay, we solved the problem here. Let's continue later for another problem in the meeting. Bye, everyone.